As you guys are doing your notes, I'm going back to the answer key really quickly for any of those that weren't able to grade homework in class today. We're grading section 2, section 1.2, homework number 2. If you need to pause on any of the evens to check the answers, go ahead and do so. I'm going very quickly. Here are the answers: 2, 4, 6, and 14. Make sure you're writing the directions in the problems, not just the answers. 14, A and B. A would be yes, B would be no. Pause it if you need it. Number 22, the x-intercept is 4, 0. Y-intercept, don't forget the plus or minus 2 from factoring or solving with the plus or minus square root. For number 42 and 43, they were finishing the graphs. 42 finished the parabola. It's going to just go down here in the fourth quadrant. 43 is a little funny. People usually have questions on it. What was in the fourth needs to be copied in the second, so you're going to go up. What was in the first needs to be copied in the third, so you're going to go ahead and complete it as my cursor is showing. Number 48, you can see the answers as such. Looking at the graph, you can solve for the intercepts. No symmetry because even though the parabola has symmetry in and of itself, in context of the x and y axis, it is not there. And last but not least, number 74, a little different than what the answer key showed. Number 74, plug in 3 as your h, negative 2 as your k. For your r, you need to plug in x as negative 1, y as 1, solve for r. Your final solution ends up being the following. And I believe r ends up being 5, so then r squared would be 25. Our last even is number 82, and you can see the information there. We went over number 85, but sadly no time right now. You can ask a classmate because we did it in detail. Alright, the rest of you guys, you should be in your notes. We're talking about slopes of lines. The nice thing is, if you guys check it out, you might be like, oh, we're so behind today. We talked so long about so many different things, except, hey look, we're done with section 3 as soon as we finish this slide. So, not too bad, huh? Parallel and perpendicular lines. Yesterday we talked about slopes are the same for parallel. Usually in a different location though. The lines are usually like separated from each other. Perpendicular, what do I mean by opposite reciprocal? Because I said it really fast at the end of class. Opposite means? Opposite what? Kind of. But how is it shown in the slopes? What becomes opposite? The number? What do you change? Thank you for coming out with that. That's the reciprocal. Reciprocal numerator and denominator flip. So this means flip it. So if it's a 2, oh, it's 2 over 1, it's 1/2. If it's 2/3, oh, it's 3/2. If it's 11/3, it's 3/11. Okay, that's reciprocal. That's flipping. What's opposite mean? The sign flips. So if the slope is positive to begin with, the perpendicular line will have a negative slope. If the slope is negative to begin with, the perpendicular will have a positive. This means opposite sign, S-I-G-N. So you might want to go ahead and, if you did not know that, opposite means a change in sign. So if you ever want to have the opposite of something, we're just going to tag a negative onto it. So negative times a negative will be positive, and negative times a positive will be negative. So negative, by definition, is the opposite direction, technically. And reciprocal, that's where you're flipping the numerator and denominator. Does that make sense? So it's the opposite sign and flipping. So as we come down here, what have you guys gotten done so far? Find slope-intercept form of the equations of the lines that pass through 2, -1, and are... parallel to and perpendicular to. You can see how you need to use this guy and that clue. form is that line written in right now? How much do we like standard form? Not at all, because you can't really see stuff. So what are we going to do to that standard form of an equation in order to make it so that we can actually figure out our characteristics? Solve for y. Great idea. Any mental mathers out there? Let me give you 15 seconds. Mental math, shouldn't it be 2/3 x minus 5/3? Ah, beautiful. It's a negative 2x divided by a negative 3. So when the negative divided by a negative, that'll change the 2/3 to positive. You've had a plus 5, but divided by a negative 3. Remember, the negative 3 needs to go to both pieces, both terms. These distribute. So what is the slope that I'm looking at right now?
2/3.
So when I have a new line parallel to, well, first of all, hold on. If they give me the point 2, -1, what form of a line do you think I'm using? Slope, intercept, point, slope, or standard? Yeah, point, slope, I agree. You could do slope, intercept, but for our purposes, I need you to get really good at point, slope anyway. So let's go ahead and just use it. So I'm going to go ahead and do y minus y1. You guys know y plus 1, right? It's minus a negative. Okay. Equals x minus x1. But what am I using for m if it's parallel? Keep it that? 2/3. Could you be super snazzy and simplify and get y by itself? Yes. And in pre-cal for checking answers in the back of the book, you probably should. Oh, and the directions say never mind, slope intercept form. Alright, we're being obedient. So therefore, I believe you end up with, double check me, 2/3 x. We have minus 4/3, minus 1, minus 7/3. Double check. To combine fractions and whole numbers, change the whole numbers in terms of the fraction's denominator, right? See writing, I just want to make sure you guys are good. Distribute your 2/3. Distributing over here, it's going to be negative 4/3, subtract a 1. 1 is the same thing as 3/3, right? So negative 4/3 minus 3/3, negative 7/3. You guys agree? Cool. If you disagree, be real, because you might have all made a mistake. On the bottom one, same point, so y plus 1, x minus 2, but what am I doing for my slope instead? Okay. It's a positive 2/3, make it negative, and reciprocal would be 3/2. Does that make sense? You guys agree? I'm going to give you another 15 seconds to simplify. Take as much time as you need. Just because I have to do mental math sometimes for sake of time does not mean that you need to do it as well. Slow and steady wins the race. As long as it's not too slow. Slower usually means fewer mistakes and more careful attention. So when you distribute, you got negative 3/2 x. When you multiply, you get plus 3 minus 1. What do you guys think? Yeah. Graphics. Plus 3 minus 1, I made it negative 2. See? Beware that mental math, huh? Thanks for being real. Alright. How are we doing on linear functions? Section 1.3. What do you guys think? Those of you that started homework last night, give me a thumbs up if you're like, yeah, it's good. Okay. Any questions so far of homework last night? Why am I asking about section 1.3? We hadn't finished it yet. If you had started 1.2 the night before, you could have started 1.3 last night. Alright, well kids, let's start 1.4. If you have trying to get section 1.1, 1.2, 1.3 were all pretty fast and pretty basic review, mostly from Algebra 1. The one thing that might have slowed us down and did slow us down was number 1, logistics, beginning of the year stuff. I'm getting used to me in my class and how I run things. But also number 2, symmetry. Symmetry slowed us down a little bit. But sadly, it's not really sad, because if everything was just simple review, you guys would get super bored super fast. It's nice for a little while, but we have to get in the deeper stuff at some point. Section 1.4 and 1.5, a bit more expensive. 1.5, we're talking about domains, ranges, mins, max, average speeds, rates. So 1.5 is going to take us probably a couple things, and 1.4. Well, you're going to see the title. Functions. With function comes function notation. F of x. That's an important one. Barely saw it in Algebra 1. Probably got confused by it a little bit. Definitely used it last year, but that doesn't mean you liked it. So to start off functions, we're going to definitely need more than one day, so thank you for letting us get into section 1.4. Let's get as much done as we can, so tomorrow's a little bit easier. Sound good? And I think section 1.3 was a little shorter too, right? I don't think there were too many problems in it. So maybe you'll be able to finish that one fast, so that you can start on 1.4 homework, which is the weekend's homework. Alright, relation just means any set of ordered pairs. You guys know ordered pairs, x and y pairs. But relations can also come in equation form as well. They don't just have to be ordered pairs. But a special type of relation, a special type of, well, shows a relationship between two pieces of data, is a function. And as you guys know, the most important thing about a function as far as its definition is each x paired with one and only one y. Which, if you were looking at a graph, you guys, do you know how to fill in the blank? What test do we use? Vertical line test. Good. Passes the VLT, passes the vertical line test. Well, shorter than I can. Passes the vertical line test. And as you guys know, vertical lines, hopefully we've tried to make it, or I've tried to make it a little more easy for you. Remember the tick marks on the x-axis are vertical, right? So a vertical line, let's just pick one like this one. A vertical line starts at a tick mark and is extended. The tick mark is x equals 3, so extended, the entire line is x equals 3. So on that vertical line, when you're sweeping your pencil across a graph or visualizing it and trying to think of, does this vertical line hit in more than one place, what you're asking yourself is for this one single x value. Is there one and only one, if any, y's? Long story short, whatever function you have, however funky it might be, it's I need a squiggle now. Oh, no, it's not. This would be probably a 1, 2, 3, 4, 5, 6th degree polynomial, x to the 6th with all kinds of messy terms in between, or following. But you're trying to ask yourself, does the function, if it hits this line at all, does it hit in more than one place? If it doesn't, what do we call it? A function. We can name it a function, and by naming it a function, we can say, hey, that's f of x. Now, I haven't given you the equation for that function, but yeah, I can name it a function. If it did hit in more than one, we could not call it f of x, and the reason being we could not get y by itself in a single equation that totally encapsulates the graph that you're seeing or the relation that you're seeing. But if the vertical line only hits once, yes, we can name it a function and go from there. And here's another fun tidbit. If it's a function, we can graph it in y equals. If it's not a function, we can't in one line graph it in y equals. You guys saw an example of that yesterday. What were we trying to graph yesterday that we could not get into one y equals and we had to split it into two? A circle. Why couldn't we get the circle into one y equals? Or is it not? A function. And that's also why if you look in your graphing calculators and hit the mode button and scroll down, do you guys see that function is selected? Do you see function? Or it might just be F-U-N-C. Okay, try changing that to the next one. Try changing it to like par or something. Par the next one, very much. Hit y equals. Ooh. You only get y by itself in function. Alright, cool kids, we barely started 1.4, but we got it started tomorrow. First things first, we're going to quickly check 1.3. It should be super easy and not many questions. And then we'll bust out 1.4. Sound good? Alright, bye, cool kids. See you later.
You guys have a busy ass to do Tuesday. So I will start today and
no, I know
Is it like you just don't do it? So when you say overdue, I thought you were on like a specific
And
time.
Colby, when you do catch up, just check out the videos.
first semester I thought I was fine at everything, so like I had like 26 overdue assignments. So at the end of it,
Who's that water bottle?
that's fine.
One that's less shiny works a little better.